Welcome to Hatfield 2.0, a bio-wise city, turning bio-wasted opportunities into bio-wise urban transformation. We are exploring the existing parameters and dynamics of bio-waste as a system in Hatfield and re-envisioning what that can look like through a bio-waste lens. This is our team, the bio-waste vision makers. As a point of departure, we use this roadmap to explore the utilization of bio-waste in the context of Hatfield. We looked at the big picture thinking. Why should we care about bio-waste systems in the bigger context? The fieldwork, mapping and stakeholders is to reveal the bio-waste systems in Hatfield. The current state, what are the bio-waste system problems in Hatfield? The future state, an ideal state for bio-waste management and utilization. And the urban strategy and target state, developing our bio-waste urban strategy through tangible interventions, thus creating Hatfield 2.0, a bio-wise city.
To remind you, bio-waste consists of green waste, such as yard trimmings, and food waste, such as plate scraps, expired food, and stale food. So, why should we care about bio-waste? The University of Pretoria generates up to 42 tons of green waste per month and about 4 tons of food waste per month. Only the green waste is collected and turned into compost, mulch, fertilizer at the facility on LC campus. The compost facility produces close to 33 tons of compost monthly. The estimated average household generates around a quarter ton of food waste and a quarter ton of green waste monthly. Other parties, such as supermarkets, produce 870 tons of food waste per month per supermarket. And restaurants produce an estimate of 3 tons of food waste per month. The maintenance of one rugby field produces almost 1.5 tons of green waste monthly.
Now, where does bio-waste currently go? Green waste is dropped off at transfer stations in Pretoria, marked with a T on the map. The closest to Hatfield being the Menlo Park transfer station, which receives a large amount of green waste daily. This is then transported to landfill sites marked with an L, situated on the outskirts of Pretoria. A fun fact for you guys, the Menlo Park transfer station is currently closed for the next 2 weeks due to it being overfull. We've realized that this is a wasted opportunity. 4 tons hourly, 12,000 tons monthly. I mean, the numbers speak for itself. A large amount of green waste is being dropped off at the Menlo Park station, containing the potential to produce 7,200 tons of compost. We spent a week in the field conducting site visits, collecting data through discussions with various role players relevant to the bio-waste management in Hatfield and surrounding areas. We then applied the bigger context bio-waste amounts we found into Hatfield specifically. This was to show where it is generated and how much. In terms of green waste, indicated in blue, the University of Pretoria and the experimental farm on the LC campus are the biggest green waste generators. Large contributors are also sports fields in the areas shown in green. Looking at the food waste, indicated in blue is the high generators, so the university, due to its large number of residence canteens and restaurants, as well as the experimental farm, which generates contaminated food waste. In the rest of Hatfield, there are large numbers of restaurants, bars, takeaways, and supermarkets that contribute to 5,000 tons of food wasted monthly. But how is bio-waste currently utilized in Hatfield? As Mireille mentioned, the university's green waste is well utilized through the production of mulch, compost, and fertilizer at the LC compost facility, which is then used in the campus gardens and sports fields. But there is very limited and insufficient biowaste treatment systems, with majority of waste ending up in landfills. We narrowed it down to 5 systemic problems that create wasted opportunities in Hatfield specifically. Ineffective waste circulation, no incentive for waste turnover, no biowaste microinfrastructure, system transportation issues, and the lack of positive culture surrounding biowaste. Other than the LC compost facility, limited successful biowaste treatment systems are present. Additional initiatives that aim to improve the system include: the Hatfield CID maintains the landscape in their vicinity and surroundings. The green waste collected is taken to the LC compost facility. Adopt a Park, an initiative by role players in the private sector who undertakes the responsibility for maintenance of public spaces and its landscaping. Private companies transport the produced waste to transfer stations. But after our stakeholder engagements, we realized that there is a problem pattern. Our biggest problem is that a high volume of biowaste is generated and not utilized optimally. There are initiatives who aim to solve it, but then regulators, such as the City of Tshwane and homeowners associations, set up regulations such as the Tshwane Town Planning Scheme of 2008 that strongly regulate any planning interventions or proposals. This poses the solution. And we're back at the same problem. We then rather turn to the private sector and communities, but the solution lies in the vision makers. We have to work together, connect the different initiatives, convince the regulators, and include the private sector and communities.
After extensive data collection and analysis, Mariette mentioned the various problem patterns that affect the urban systems of Hatfield. As vision makers, we ask ourselves, what vision do we have for the future state of Hatfield? Through our strategies and interventions, the future state of Hatfield is inclusive, systems are integrated and circular, an emphasis is placed on accessibility and safety, spatial quality is considered, and a strive towards a resilient and sustainable city is promoted. So that leads us to our question. What does our urban strategy, bio-wise urban transformation in Hatfield look like? Our team identified 3 primary role players that make up the core components of urban systems in Hatfield: people, waste, and the urban fabric itself. With close consideration to the various dynamics of these role players, 2 primary urban strategies form the basis of our proposals. The former focuses on promoting human-centric design and waste culture, while the latter focuses on maximizing bio-waste utilization. A set of interventions for the former strategy includes developing a central square and green corridor, redesigning the current waste circulation to promote a healthy waste culture, and improving road and transport networks in response to people and the environment. While the interventions associated with the latter strategy includes integrating and expanding existing LC facilities, repurposing biowaste for energy production, and utilizing biowaste for streetscape design. So, our urban strategy looks at how these interventions could spatially reshape the urban landscape of Hatfield. A pedestrian-oriented green corridor will connect the Hatfield Centre to the LC compost facility running along the present-day Burnett Street. To accommodate and redirect current circulation, the west and east side of Hatfield will be bridged along Park Street, taking up the role Burnett Street is currently encompassing. University Road will also be bridged onto Park Street to ensure efficient circulation and no dead spaces. Further consideration is also given to the surrounding open spaces, and small, primarily pedestrian-oriented activity spines connect these spaces to the central green corridor. The redeveloped old Hatfield Square formed part of the spatial identity of Hatfield, and thus our interventions also places focus on recreating a green central space of identity, with resilience and sustainability forming the base of its design. The primary movement network reimagined would encompass the following. While closer emphasis is placed on various newly proposed road closures and smaller changes in circulation, and so the general movement network of Hatfield would look something like this. To accommodate both pedestrians and waste systems, a tram proposal would run along the green corridor and circulate within Hatfield. This tram would not only provide public transportation, but would also pass along various food waste drop-off points that are strategically placed within close proximity of high waste areas identified in the data analysis phase of this project, as well as green waste drop-off points, which will allow for both food and green waste to be transported via the tram system to the LC compost facilities and utilized instead of ending up on various landfills. Pedestrian-oriented developments would take shape along activity spines and corridors to ensure maximization and efficiency of resources and infrastructure within Hatfield. A closer look at LC identifies 4 primary role players, namely the Innovation Hub, Future Africa, Engineering 4.0, and the LC Compost Facility that are of key importance. Interventions and strategies therefore focus on redesigning the LC road network to connect these facilities and centrally develop a new role player, namely a biogas electricity plant that utilizes the collected waste and provides sustainable electricity to general functions within Hatfield, such as robots, lights, buildings, the tram system, and various other elements. The combination and integration of all of these strategies and interventions result in major spatial transformation within Hatfield, giving meaning to the idea of this LC superform and re-envisioned Hatfield 2.0 future state.
Urban strategy through tactile interventions. We investigated 3 points of interest on the green corridor to see how the strategy could be implemented on a human scale. The first point of interest is in the urban square on Burnett Street. Here we look at a current section through Burnett Street. Highlighted in orange, we can see that there are sidewalks that act as active zones and parking on both sides of the one-way street, prioritizing vehicles. Vegetation is limited to a few trees and shrubs on the right-hand side of the road. Closing Burnett Street and turning it into a pedestrian-only street will allow the spaces to change as follows. The storefronts of buildings, highlighted in yellow, will extend outward into public space. There are wide activity zones that allow for pedestrian movement. Buffer zones in green act as thresholds between active zones and increase the green space in Hatfield. A tramway to connect Hatfield campus with LC doubles as transport for biowaste and pedestrians. The increase in green infrastructure means there will be an increase in green waste that will feed the bioenergy plant on the superfarm. Streetscapes are made from biomaterial that otherwise would have landed in landfills. Moving on to how these spatial changes will affect a street corner. Currently, at the corner of Burnett and Hilda Street, the storefronts highlighted in yellow only extend a small amount outside of the building. The rest of the sidewalk in orange is harsh open space, with minimal trees, lots of signs and dustbins as street furniture. Using Burnett Street to prioritize pedestrians will allow the street corner to change as follows. Storefronts, again in yellow, extend over a larger area, creating an environment that will entice people to stay. The planted buffer zones allow for shaded activity zones that promote pedestrian activity. And street furniture, highlighted in bright yellow, is made from biomaterial that otherwise would have landed in landfills.
Moving on to the second point of interest. Situated between the urban square and LC, where we propose a residential redevelopment as a continuation of the corridor. Currently, it is mostly low-density residential houses that make up this part of Hatfield. As part of our strategy, we propose to redevelop this area with a more pedestrian-oriented approach that allows the continuation of the corridor as a multifaceted implementation. Rezoning this area allows for higher density pedestrian-oriented land uses like apartments and commercial spots that draw people to use the corridor to its fullest potential. The walkway allows for an organized layout of the new development and creates an opportunity to lead the pedestrians through the corridor and utilize the sustainable street furniture. The street furniture links directly to the superfarm as it can be made from repurposed bio-waste construction materials. Adding more living biomatter horizontally and vertically provides not only a green atmosphere to Hatfield, but also acts as a bio-waste generator to fuel the superfarm. By using new techniques like one developed by a Dutch company, Studio Hendrix, it allows us to add self-sustaining moss to new or existing structures without compromising the structural integrity, which softens the current hard city streetscape edges. The tram mentioned before connects pedestrians and biowaste straight through the redeveloped area, as well as the entire corridor, while an emergency lane is kept that can be opened and closed for specific reasons such as medical emergencies. The tram is used as a main source of transportation for the biowaste. It collects the waste at drop-off points as indicated in orange, where anyone can go to dispose of their green waste, which in turn directly feeds the LC Superfarm. Our proposed modular design bins allow for the waste pickers to take a trolley temporarily from the bin for collection of the bio-waste from surrounding smaller bins along the corridor and bring them back to a centralized point. The bigger bins connect to the tram line through intersecting tracks, allowing for easy connection to the tram itself and transportation route.
To change the waste culture, we include different role players such as pedestrians, waste pickers, and businesses. Supermarkets, restaurants, and campus canteens are incentivized to sort their food waste into contaminated and uncontaminated to use in the superfarm. In return, they would receive packaging and storage materials produced from biowaste on the material fabrication plant. By designing a modular and movable food and green waste drop-off station, a prominent and fixed role in the system is created for waste pickers. Thus, a functional circular economy is created. To maximize the potential use of biowaste, our strategy repurposes biowaste for energy production through a superfarm on LC de Villiers. This will entail a larger capacity compost facility, a wastewater treatment plant, material fabrication plant, and a biogas waste-to-watt plant. The superfarm integrates the necessary structural elements for the required program with the current functions of LC, such as the sports fields and agriculture fields. By utilizing more of the vertical plane, concealing and revealing functions, and creating pedestrianized routes through the plant, a friendly interface is created, allowing the public to learn from and experience the superfarm as a whole. By continuing the green corridor into LC, waste is brought into the superfarm by means of the tram, processed through the plant, and energy is pumped back into the system, benefiting the entirety of Hatfield through this exchange. So what is our impact? As a whole, our interventions lower CO2 emissions, puts less strain on landfills, produces more compost and fertilizer for use beyond just UP campuses, produces clean water and energy to aid in current load shedding and water cuts we are experiencing, and creates a new culture around biowaste. To conclude, the impact of this urban strategy will create a combined nearly 17 million kilowatts of electricity per year by using just food waste and only half of Menlo Park transfer station's green waste. This will allow the self-sustainability of the green corridor by powering the 48 passenger tram and 100 streetlights for 12 hours a day, 365 days a year. And with what is left over, we can carry 21% of UP's annual electricity consumption. Hatfield 2.0, a bio-wise city.